Law of motion. Forces come in pairs. So far, you have been exploring how forces always occur as an interaction between two objects. For example, if you apply a net force to a box, it will move in the direction of that net force. In the third Explore lesson, you observed examples in which a force was applied in one direction and motion occurred in the opposite direction. For example, when a person on a skateboard pushes against a wall, the skateboard moves in the opposite direction. What is going on? When the person on the skateboard pushes on the wall, the person moves in the opposite direction. Equal and opposite forces. In the first Explore Explain lessons, you learned that Newton's first law of motion states that an object at rest will remain at rest and an object in motion will continue moving in a straight line in the same direction unless an unbalanced net force acts on it. You have also learned that the forces always occur as a result of interactions between two objects. In the first two images of a person on a skateboard, it may seem obvious that the person interacts with the wall when pushing the wall. What may not be obvious is that the wall simultaneously exerts the same amount of force on the person. Newton's third law of motion states that when one object exerts a force on a second object, the second object simultaneously exerts a force on the first object. This force is of equal magnitude, but in the opposite direction of the force exerted by the first object. In the skateboard example, it is the wall that pushes the person on the skateboard. The skateboard moves in the direction of motion, represented by the red arrow in the image that follows. In this set of images of a person on a skateboard, the blue arrow represents the force that the person applies to the wall. The red arrow represents the force that the wall simultaneously exerts on the person. The wall exerts a force that is equal in magnitude but opposite in direction. When the person on the skateboard exerts a net force on the wall exerts a net force on the person that is equal in magnitude but opposite in direction. At first, it might seem that these two forces would cancel out, resulting in a net force of 0. If this were true, the skateboard's motion would not change. It would remain at rest. You have learned from Newton's first and second law that the way to change the motion of an object is to apply a net force. How is there a net force here? Notice that the forces in this example are not acting on the same object, the person on the skateboard. The blue arrow shows the force that the person exerts on the wall. The red arrow shows the force exerted by the wall on the person. What forces are acting on the person then? Only the red force. There is no force on the other side of the person to balance it, so the person experiences a net force from the wall and moves in the direction of that net force. What effect does the force represented by the blue arrow have on the wall? We cannot see the effect because it is so small, but in fact, the wall bends in slightly. It is true, you can bend a wall, just not very much. To prevent the person from moving as a result of the push on the wall, another person could stand on the other side and exert force. The third image shows another person exerting a force on person A, the person on the skateboard. This other person exerts a force on person A that is equal and opposite to the force exerted by the wall on person A. The light blue arrow represents the force the other person exerts on person A. Look at the diagram of the skateboarder. Focus on the dark blue and red arrows. What forces do the arrows represent? Now the diagram shows two forces acting on person A. The two forces are equal in magnitude but opposite in direction. The net force on person A is 0, so the person will not move. Newton's third law and rockets in space. For a long time, many people believed that a rocket would not work in space. One idea at the time was that the rocket would have nothing to push against to move. But rockets do work in space. Inside a rocket, fuel is ignited in a chamber. The gases in the chamber explode. This explosion creates a pressure that forces the gas out of one side of the rocket. The rocket moves in the opposite direction. The force pushing the rocket is called thrust. The rocket pushes on gas in one direction. The gas pushes on the rocket in the opposite direction and the rocket moves. A rocket pushes on gases in one direction as shown by the red arrow. The gases push on the rocket in the opposite direction as shown by the blue arrow. A rocket does not need anything to push against. It carries fuel, which it turns into exhaust. Then its exhaust pushes it, and that is all that is needed to move the rocket. Summary. Newton's third law of motion states that when one object exerts a force on a second object, the second object simultaneously exerts a force of equal magnitude, but in the opposite direction, on the first object. The forces described in Newton's third law are equal in magnitude and have opposing direction, but they do not cancel out because they act on different objects.